All right, so talking about environmental physics, there's another term that we have to talk about, and that's albedo. Albedo is a measurement of how much energy is reflected off a surface. So when we got incoming solar energy, which is the primary source of energy, excuse me while I'm tying my hair back, is the primary source of energy for the Earth. I mean, with the exception of nuclear energy, we're talking about uranium and those sort of materials, solar energy provides almost the entire breadth of energy that we experience. So, I mean, the formation of coal is nothing more, coal and oil for that matter, all your fossil fuels are basically, ancient sunlight being stored by algae that's, eventually died off and has been compressed and experienced high levels of heat, and that's where we're getting our coal from. But it is from sunlight. It's just an ancient source of sunlight that we've had, stored in our Earth for so long. It's also an ancient source of carbon that we've managed millions of years ago to remove from the atmosphere and bury under the Earth, and now we're re-releasing that back into the atmosphere. So that's when we talk about, our carbon footprint. We're talking about the introduction to ancient carbon back into the atmosphere, and that's why biofuels. Here I'm on a tangent. That's why biofuels are preferred, because we're not introducing ancient carbon back into the atmosphere. We're taking carbon out of the atmosphere, putting it back into a plant, burning that plant off, and re-releasing that carbon back into the atmosphere. It's a cycle effect. Where fossil fuel, sure, we can view it as a cycle, but that cycle is millions of years. We've taken that carbon and have stored it for millions upon millions upon millions of years, and now we're re-releasing it. And our environment has changed drastically during that time. So that's why we're a little concerned about the amount, well, more than a little concerned, about the amount of carbon in our atmosphere. Anyway, but talking about the reflective property of a material. And I've given a chart here of some of the percentages that we're talking about when we talk about reflective properties. The first one is the ocean. The ocean reflects 10% of the amount of solar energy that strikes it. So when light hits the ocean, 10% of that solar energy is reflected back into space. Well, depending on your greenhouse gases are coming out. 10% of it is reflected back. It's not put into our environment. Okay? So 90% of the energy is used to heat up the ocean. The remaining 10% is then liberated. So if you can imagine, let's say 100 joules per second is striking a particular area, 90 joules is being absorbed by that chunk of urban centers, our major cities. They absorb a great deal more. They absorb 85% of all energy that strikes them. You're talking heating up concrete, heating up whatever areas are there, heating up asphalt. All of those things have low reflective values. So most of the energy that strikes an urban area is being converted into heat, which is why there's a movement now to green up cities, to cover over large stretches of concrete and asphalt with grasses, so using green rooftops, because that way it'll change the albedo value. It'll increase the percentage of energy that's actually being reflected. It makes it a more, the idea of not heating up the area around us. Cities are hot, and the reason why they're hot is because, well, pollution and all, human population, but also it doesn't reflect energy very well. Forests, when you're talking about a wooded area, only 5% of the forest is reflected back. That's a lot of energy if you think about it. So once you destroy a forest and build a city on that forest, that area is now absorbing 10% more energy than the forest originally was absorbing. So you got a problem. We're absorbing more and more energy. Okay? Ice, 90%. 90% of the energy that strikes ice flows, is reflected. Just waiting for my video because it's going crazy right now. I think it's fixed. Okay? So melting of the polar ice caps is concerning. Between the ocean water and ice, we're going to be absorbing 80% more energy into the oceans if we melt the caps. We're getting the same amount of energy to strike the Earth, but only 10% is staying with us. This heating up the ice is going to be absorbing 80% more energy. Not necessarily a good thing. And the last value is the value for our planet. Our planet is about 30% or 31% reflective. Of all this, the planet, only about 70% is actually absorbed. Now, the polar stretches of forest certainly help. Especially if it's a light sand desert, if it's a dark sand desert, it's a little bit different. So those reflecting light back into space, where we're ending up with this 30% is being reflected because of large patches of forest and ice, where the ocean itself is absorbing a tremendous amount of energy. All right, so really quick, that's albedo. Of a surface is how reflective it is to energy. So a 0.1 is 10%. So that means 10% of the energy is reflected.